Let S of mass m equal 200 gram, m equal 200 gram. We must convert the mass from gram to kilogram by divided by 1000, so equal 0.2 kilogram. Is free to move on a track AOB lying in a vertical plane. This ray is formed of two parts. The first one, AO, is straight and horizontal, and the other OB is straight and inclined by an angle alpha with respect to the horizontal. We have sine alpha equal to 0.1. Along the part AO, S move without friction. So on AO, friction equal to 0. And along the part OB, S is acted upon by a force of friction F that is assumed constant and parallel to the path. So on OB, friction exists. The object of this exercise is to determine the magnitude F of the force F of friction. Part A, launching the solid. In order to launch the solid on the part AO, we use spring of constant K equals 320 Newton per meter and of free length L0. One end of the spring is fixed at A to a support. We compress the spring by x0. We place the solid next to the free end of the spring and then we release them. When the spring attains its free length L0, the solid leaves the spring with the speed v0 equal 8 meters per second. So v0 equal 8 meters per second. When the length of the spring is L0. In this case, x equal to 0. When the length of the spring equal to L0, in this case, x0 equal to 0. Why? Since in this case, the spring is not compressed and not elongated. It just slides along the horizontal part and then rises up at O, the inclined part of it. Part 1 determines the value of x0. Okay. Part 1. First, we have friction equal to 0. Then, mechanical energy is conserved. Then ME before equal ME after. ME before we have kinetic energy plus EPE, elastic potential energy, and after at point O we have KE plus EPE. In the two cases before and after, the gravitational potential energy equal to 0 since the object is on the reference. So we neglect the gravitational potential energy. Before, kinetic energy equal to 0. So we have only elastic potential energy. Kinetic energy after equal to half mv0 square plus EPE after equal to 0 since x0 at O equal to 0 free length. So we obtain x0 square equal to mv0 square over k. We simplify half and half. So x0 equal radical m over k v0. So x0 equal 8 radical 0.2 over 320 equal to 0.2 meter. Okay, this is the first part. Part 2. The solid reach O with the speed v0 equal 8 meter per second. Justify. Okay. On AO, part 2. On AO, friction equal to 0. So, by Newton second law, summation force exterior equal MA. The forces, they are friction plus weight plus reaction of support equal MA. So projection along the motion weight and reaction of support. Simplify. So friction, it's opposite to the motion, minus F equal MA, while friction equal to 0, so we obtain A equal 0, the acceleration equal to 0 meter per second square. So the motion is URM, uniform rectilinear motion. Therefore, velocity is constant, so V at O equal V0 equal 8 meter per second. B. Motion of the solid along the inclined part OB. S moves at O up the inclined part OB with the speed v0 at the instant t0 equals 0. A convenient apparatus is used to trace as a function of time the curves representing the variation of the kinetic energy of the solid and the gravitational potential energy GP of the system solid Earth. These curves are represented in the adjacent figures between the instants t0 equals 0 and t4 equals 4 seconds according to the scale. One division on the time axis corresponds to 1 second and one division on the energy axis corresponds to 1 joule. The horizontal plane through point O is taken as a gravitational potential energy reference. Here is the gravitational potential energy reference, and G, we have G equal 10 meter per second square. Part 1, the curve 1 represents the variation of the kinetic energy of S as a function of time. So Y B1 at t equals 0, the solid passes through O with the speed V0 equal 8 meter per second. Then at t equals 0, kinetic energy different than 0. So the curve 1 is not passing through O. Therefore, curve 1 represents the kinetic energy. Part 2a specifies the form of the energy of the system at the instant t4 equal 4 seconds. Justify your answer. At t equal 4 seconds, the kinetic energy equal to 0. So the form of energy is the gravitational potential energy. So at t equal 4 seconds, we have kinetic energy equal to 0 joule. Therefore, at t equal 4 seconds, the energy is the gravitational potential energy Gp. Part 2b determines the maximum distance covered by the solid along the part OB. We know that maximum distance GPE is maximum, then kinetic energy equal to 0. So graphically, kinetic energy equal to 0 when GPE equal approximately 3.2. So graphically, GPE max equal 3.2 joule. While GPE max equal mgh max, and h max is h per d max, and they are this alpha. We have sine alpha equal h over d max, so h equal d sine alpha. So GPE max equal mg d sine alpha. Now 3.2 equal mass equal 0.2 g10 is sine alpha, it's 0.1. So we obtain d equal d max equal 16 meter. CI, complete the table with the values of the mechanical energy ME of the system at each instant t. So we have ME equal GPE plus KE. So at t equals 0, graphically GPE equal to 0 and KE equals 6.4. So ME equals 6.4. At t equal 1, it's 5 already, joules. At t equal 2, mechanical energy equal, so we have at t equal 2 second, GPE equal 2.4 and KE equal 1.6. So mechanical energy equal 4 joules. At t equals 3 seconds, GPE equal 3 and kinetic energy equals 0.4. So we obtain 3.4 joule. At t equal 4 seconds, GPE equal 3.2 and kinetic energy equal to 0, so it's 3.2 joule. I justify the existence of a force of a friction. Friction is exists since mechanical energy is not constant. We have mechanical energy at t equals 0, 6.4, and mechanical energy at t equals 4 seconds, 3.2 joule. So the mechanical energy decreases with time. So friction exists since mechanical energy. The mechanical energy is not constant, is not conserved. Decrease with time. Part 3i. Calculate the variation in the mechanical energy of the system between the instant t0 equals 0 and t4 equals 4 seconds. The variation of in mechanical energy is delta ME equal ME at t equal 4 seconds minus ME at t equal 0. It's mechanical energy after minus mechanical energy before. So obtain 3.2 minus 6.4 equal to minus 3.2 joules. Delta ME. For determine F. F exists, so ME is not conserved. Mechanical energy is not conserved from part 3i. Is not constant. So we have delta ME equal summation of work of non-conservative forces. So delta ME equal work of friction. So delta ME equal minus FD, since the work of friction is minus F times D, minus 3.2 equal minus F times 1.6, since the distance from O to at t equal 4 seconds is that this D max, then friction equal 0.2 Newton.